Let's look at different version of motion of charges in a magnetic field, different possibilities. One of the possibilities, it is parallel to B. Another is purely perpendicular. Another is at an angle. Okay. So let's look at that. So one thing that we need to remember is the work done by a magnetic field on a moving charge is always zero. So let's look at that. Let's consider a positive charge particle moving in a uniform magnetic field, say B. So the cases that we're looking at is case 1, when B is parallel to B. So this makes the angle to be 0 degree, if not 180 degree. But sine 0 is 0, so force will be 0 again. So what does this mean? That there's no change in direction as well. So the particle will continue to move with no change in direction. Change in direction is nil. Triangle means change. Change in direction is equal to nil. Okay, I have written the statement here. Thus the moving charge particle will not exert any force, not experience any force, sorry. And so it continues to move without any acceleration. Now, what about perpendicular? We just saw this actually. So when we talk about perpendicular, right, we have the magnetic field in this direction. This is your V. So what happens? It's either in or out, either in this way or that way. So we need to figure out what is the direction of the force. And this will be the maximum best possible scenario for changing the direction. So let's use our right hand palm rule. So I'm pointing my right hand that way. So this way, pointing my thumb in the direction of velocity. And my palm is facing what? My palm is this side or that side? Please do it. It will be facing towards us. So that is the direction of force. So if such a direction is applied everywhere, what will happen? Yes, it will take a motion in this way. Does it make sense? It will go in this way. So it's pointing towards the center. So it will take a circular path. A charged particle moving perpendicular to a magnetic field experiences a magnetic force that is always perpendicular to both its velocity and its magnetic field. This particle kinetic energy will not change again. That we know. Right? It will take a circular path. Did I make that? So basically it moves a circular path. You guys make a note of that. Just a second. A charged particle moving perpendicular to a magnetic field experiences a magnetic force. So it takes a perpendicular circular path. So you can write that over here. It takes circular path. So basically this force acts like a centripetal force. So this will be your let me yeah, that acts like a centripetal force and it takes a circular path. Again, questions can come in any ways, so we need to be very clear with it. Finally, we have the combination. It's neither moving parallel or perpendicular. It's moving at an angle. Right? We have seen this. So I'll try to do it here itself. We have a charge moving, say, to the or let me have the magnetic field in this direction. So the charge is, say, moving at an angle in this way. So what can we do? As usual, we should resolve it. One is along the direction of your magnetic field. Another is perpendicular to it. Right? This is, and by the way, the angle will be something like this. So that would be cos of theta, right? In the direction of magnetic field. and this is perpendicular direction of magnetic field. Remember, theta is over here. I'm not able to draw it over here, so do it in the light layer. Okay, so basically that's your theta. Okay, guys. Let me make it a bit more clear. So that would be your theta, right? So you can draw everything in pen. This you can draw it in pencil to indicate the angle. It'll look good. So now what can we tell? We know that the charge, this will not get changed. Change over here is nil. What about this? This is the direction in which matters. So what is happening over here? Think about it. What will happen? The component of velocity. The velocity can be decomposed into two components, one parallel to the field and one perpendicular. The parallel component, what happens with that? The parallel component is unaffected by the magnetic field and continues to move in that straight direction. So how does it look end of it? Perpendicular component, the perpendicular component causes the particle to move in a circular path. Discussed in case 2. End of it, what we get is a helical path. That is nothing but charge will move in this direction. Not that. This direction. That's your helical path. It will continue to move forward. This is your V cos of theta. But the magnetic field will make it go round and round, and that's what is happening. Okay. So at the end of it, this is our motion for case 3. It's pretty good. We're going to study everything in detail, but this is just an overview. I've written over here, just an overview. Okay, so let me make it a bit more clear. So this is how it's rotating, I guess. Provided this is our direction of, oh yeah, this is it. That's our direction of magnetic field as well. So like this, and it will go downward. Wait, let me think of it. So the velocity is downward, magnetic field is over there. It is facing our side. Okay, yeah, this is correct. So it will keep moving to the right. Oh, already indicated over there. And it will keep going this way, this and this. So that's our helical path, as simple as that. So a particle, moving charge, can enter the field of magnetic field, that is, can enter a magnetic field in 3 different ways. One is parallel to the field. In that case, nothing happens. It just passes through. It won't even bother with that. It just passes through. When it's perpendicular, when that happens, it gets stuck in a loop. It won't move anywhere. It'll be going round and round in that plane itself. When it comes to your angle, neither 0 degree or 90 degree. So when this happens, it will take a helical path. The component which is along B will make it to continue to move in that direction with that particular speed. The one which is V sine theta and along with B will make it go round and round. Okay guys, so that is the entire funda. So these are all overviews. As you can see, this is also an overview. This is also an overview. We'll be talking about this in detail. For now, you guys just copy.